Okay, the next big thing in SQLite, especially when we're trying to reverse engineer these SQLite databases, when we're investigating different applications, trying to get forensic data out of them, is we really need to understand timestamps in SQLite and how, in the various ways in which these timestamps are put into a database. So what I have here is a list of like common timestamp formats that databases use, especially SQLite. And this is all stuff, just so that you guys know, when developers make an application, like when we make our Monolith Notes application, as engineers, we get to decide how we want to store these timestamps. There's nothing in SQLite that dictates a timestamp has to be in a particular format. We can store them however we want, and then the application will then parse that timestamp in whatever way we decide to parse it. So what that means is that you can have timestamps literally stored in any possible way you can think of, but because engineers are lazy, we tend to just stick with like the most common formats because they're known, we all understand them, we don't have to think of something new out of the box. So I've got a table here that generally lists the most common types of formats, starting with Unix time, which is just the number of seconds since 1970. That's a pretty common one that you'll see a lot. This was sort of one of the initial timestamp formats that we've used in computing. Now, eventually we came up with milliseconds because if we want better resolution, if we have there's certain applications that have intense amounts of logging and things like that, you want better resolution so that you can differentiate, the order of which events happened. So having millisecond resolution on a Unix timestamp can be helpful. And a lot of places, even though they don't need that resolution, they still just default to that timestamp just because it's a standard. So in the way to tell the difference between these is just look for the length of the string and just look for, when you look at these timestamps long enough, you can kind of understand from there, just by visually looking at them, which version of timestamp they are. Then you also have microseconds. This one's used a little less often, but you'll still see it. Again, it's just another level of precision on the timestamp where you get even more resolution in terms of ordering of events. But they're all pretty much the same thing. You're just calculating different numbers, different values, and the magnitude is just different when you're doing the conversion. You also have a what's called an ISO 8601 string, which is just a text value that represents the time, that it's in this specific format.